All right, so now we move on to lesson 4 of relations and functions, and it's equation of a line in slope-intercept form. So what we're going to do in this lesson is we're going to look at writing the equation for a line in slope-intercept with graph coordinates and a set of intercepts. We're going to use that equation to determine whether points lie on that line, identify that slopes and y-intercepts have a certain form and they are in a certain place of any given equation, draw a graph from its equation, and then determine the missing equation values given clues about the line. So let's go down to our first piece of today's lesson, and what we're going to do is we're going to make a table of values, state the coefficients of x and the constant terms in each of the equations, and then state the slope and the y-intercept. So right away, if we want to build the table of values, well, how we build this is we take each of these x values and then plug them in for the x in our equation, and it will give us an output value of some y. So if I put in -2 to the equation, well, I would go -2 times -2, which is +4, plus 3, which is 7. -1 times 2 is +2, plus 3 is 5. And then if I plug in 0 for x, well, 0 would just cancel out this first bit here, and I would be left with 3. Now, we can clearly see a pattern of it decreasing by 2, so I could then say, well, when I plug in 1 for x, it would give me 1, and then if I plug in 2, it would give me -1. And you could confirm that by directly putting them in, but we could see some form of pattern being established. Now remember, these represent together x and y, an ordered pair on the graph, or a specific point. So what we're going to do is we're going to go to -2x, and maybe it would be important to label our axes here. We're going to go to -2x and 7y, and that's actually beyond the graph. It's somewhere up here. We then go to -1 and 5, which would put me at -1 and 5, which is right at the top of the graph. We go to 0 and 3, which would be here. We can go to 1 and 1, which would put me here. And then finally 2 and -1, which would put me here. So if I draw a line through these points here, it would look like the following. Now, what they wanted us to determine was state the coefficient on the x term and the constant term of the equation. So if we look at this, our coefficient is the -2 out front. So we're going to put -2 is our coefficient here. And then our constant term is the 3. On the graph, what we're going to do is label the slope and y-intercept. So our y-intercept actually is where it crosses the y-axis, and that was at 3. So we can say that our y-intercept is equal to 3. And then our slope of this, now we need to pick 2 points and calculate between them. We see from left to right, this is a decreasing graph, so we should expect a negative slope. I go down by a certain amount of units, over by a certain amount of units. I decrease by 2, go over by 1 in the run direction. Therefore, my slope is equal to -2/1, which is just -2. All right, now going on to our next one, we're going to do the same thing. We're going to take each of those x values in the left column, plug them in for x here, and now we should get a certain output for y. So in the table, if I plug in -2 for x, well, I get -2 times 1/2, which is -1, minus 2, which is -3. If I plug in 1 for x, I get -1/2 times -1, and a -1/2 minus 2 is -2.5. If I plug in a 0 for x, I'll get -2, and then we can see the pattern of it decreasing by a 0.5 on each of the numbers, so I'm just going to decrease them by 0.5 each. Now, on our graph again, I'm going to label my x, my y-axis, and now we're going to plot these points. So if I plot the points here, I have -2 and -3, which puts me here. I have -1 and 2.5, which puts me here. 0 and 2, which puts me here. 1 and 1.5, which puts me here. And finally, 2 and -1 here. And if I draw a line to connect these, it would look like the following. Now, we want to determine, first of all, the y-intercept. So the y-intercept occurs right here. Our y-intercept is equal to, what we want to realize is that our y-intercept is always where x equals 0, and we discussed that in previous lessons. So where x equals 0, our y is -2, and so we can put that on the graph here. Now, what is our slope? We can calculate that between any 2 points. Let's say we calculate it between these points and this point. Well, we go up 1 unit and over 2 units. So our slope, or our m, is 1 rise over 2, which is equal to 1/2. So in fact, we wouldn't even need to put this because we didn't have to reduce it at all, so we're good there. So our m equals 1 over 2, which is just 1/2. All right, and then lastly, if we plot these in a table of values here, we have our x's, which we'll plug in for each x here. Now, if I plug in -2, I'll get -8. -1, I'll get -4. If I plug in 0 for x, I'll get 0. 1 for x, I'll get 4. And finally, 2 for x, I'll get 8. We realize these are an ordered pair again, and we can plot it. So in the red here, I'm going to plot this again. We have -2 and -8, which would be somewhere down below the graph. -1 and 4, which would be here. 0 and 0 is actually right on our origin point. 1 and 4, which would be up here. And then finally, our 2 and 8 would be well beyond the graph. So what we're going to do is just connect those points. Our y-intercept occurred right at the origin, actually. Our y-intercept was equal to 0. And how do we know our y-intercept? It's where x equals 0, our y-intercept is. And in this case, when x equaled 0, our y-intercept was 0, meaning the y-intercept was right at the origin. Now, our slope, we can see that from left to right, it is increasing. So we should expect a positive slope. Let's calculate it. So now when I want to calculate the slope, I have to go up by a certain amount of units, over by a certain amount. I would realize that I have 4 units up over the 1, so my slope is equal to 4 divided by 1, which is just equal to 4. All right, so a linear equation always has the form of y equals mx plus b, and we call this slope-intercept form. Now, to be really clear here, our coefficient of x, or our m value, is equal to the slope. Our constant term, or the b value, is equal to our y-intercept of the line. So let's actually look at an applied example below and see if we can graph a bunch of equations and determine their slopes and y-intercepts. So in the bottom table here, we're going to go line 1 by 1. So we're going to start off with line 1. The equation of the line is equal to 2x minus 7. The slope is the m value, so it's the coefficient of x. So we're going to put 2 for our slope, and our y-intercept is always the constant term, or -7. So when we go to plot this graph here, what we're going to do is we're going to start by drawing at -7, which is our y-intercept. We're going to put a point there. So we go 1, 2, 3, 4, 5, 6, 7 down. There's our point. We have a slope of 2, so we rise up 1, 2, over 1. And then what we can do is actually just draw a little line to connect those two. And we will call this graph A. Okay, let's go on to line, and actually, you know what I'm going to do is I'm going to go back here and we're going to label it as line 1, just to be really specific to our chart on the left here. We go to line 2, which we will do in blue. We have a slope, which is our coefficient of x of 3/4. We have a y-intercept of -1. So I go to -1, and that's my y-intercept. I'm going to put a dot there. We rise up 3 units over 4 units. And there is my second point. I can draw a plot here. And we're going to call this L2, or line 2. All right, now for our next one, we're going to maybe use purple as our color. And when we look at line 3, it actually doesn't have an x term, meaning the slope is 0. There's no m value. We only have a constant term with no variables, meaning that's our y-intercept. What is this going to look like? Well, in purple, we're going to go down 1, 2, 3, 4, 5. And if there's no slope, what is it? It's a horizontal line directly across, representing L3. For L4, which we will do in maybe the salmon color, we realize we have a constant, or no constant term, but a coefficient for x, meaning we have a slope of 4, or the m value is equal to 4. And if there's no constant term, that just means it's 0. So we have a b value of 0. So what we're going to do is we're going to start the graph at 0, or that y-intercept of 0, the b value, and we're going to do a slope of 4, which is technically a slope of 4 over 1 if you really wanted to think about it. So you could say m is equal to 4 over 1, because that's actually the same thing here. We rise by 4 units over 1. So in the pink here, we're going to go up 4 units, 1, 2, 3, 4, and over 1. There's our second point. We can connect those two lines here, and we're going to call this our L4. All right, and then lastly, line 5, we're going to do this one in maybe a forest green. So we look at our coefficient of our x, it's -4/3, and we have a constant term of 4, which is our y-intercept. So we're going to go to 4, 1, 2, 3, 4, and put a dot. And now we know this is a negative b, or a negative m value. Negative m values is a negative slope. So I'm going to go down for 1, 2, 3, 4, and over 3 units, 1, 2, 3. So there is my second point. And now I can connect those two and call this L5. There we go. So there's all our lines together. We have horizontal, we have a bunch of positives, and then one negative slope. So a few in the mix there. Now, if we move on to example 2, our problem is going to be just slightly different here. Now they're going to give us the graphs and then say, if we're given the graphs, now what is the slope, y-intercept, and the equations? So starting with A, we look for its intercept or y-intercept and see that it is at 1. So we're going to go over here and we're going to select, we have a y-intercept of 1 for A. The slope, remember we can calculate that between any 2 points. A goes in a sloping downwards motion from left to right. So we know it's going to be a negative slope. Between this point and this point, we have to decrease by 4 units and over 2 units. Meaning, I have a slope of -4/2, which is equal to -2. Now, if I put this in an equation, it's going to be y is equal to -2x plus 1. Because we know the equation of a line is always y equals mx plus b. And we know the y-intercept is the b value, the slope is the m. Now, let's look at line B here. Line B, it looks like it is a positive slope because from left to right, it increases. The intercept is at the origin, so what we're going to do is put a y-intercept of 0. We want to calculate the slope, which from the origin to maybe, let's say here, we have to increase by 6 units and go over by 1, meaning the slope is equal to 6/1 or equal to 6. So I'm going to go back over here and say we have 6, and therefore y is equal to my m value times x, and then we don't need to put the plus 0 there because it would just eliminate anyway. Looking at line C, we're looking at the green line. From left to right, it is increasing. Its y-intercept is at a +3 there, so we're going to put +3. The slope is indicated by, let's say we go between this line and this line, we go up and over, up 1 unit, over 2, which means our slope value is equal to 1/2 or 1/2. So I'm going to go back over here, put 1/2, and now we have y is equal to 1/2 x plus 3. D is the purple line here, and it slopes downwards, or from left to right, it is going in a decreasing order. It passes through -5 here, so its y-intercept is -5. The slope, maybe we can calculate it from here, between this point and maybe this point here. We have to decrease and go over, decrease by 1 unit, over by 4, meaning the slope is equal to m is equal to -1/4 for the D line here. So we get -1/4. Now, and maybe I'll make this point at the end, so I'm going to save that and I'll make it right at the end here. -1/4 x minus 5. Finally, E. E is our salmon line, and it is increasing from left to right. Has a y-intercept of -3, so I'm going to put in -3 here for our y-intercept. Its slope, we can use any 2 points here that are definite points, so maybe here and here. We have to go up by 2/1, meaning the slope is equal to 2/1, or just simply 2. And so I go back here and I say it's equal to 2. Y is therefore equal to 2x minus 3. Now, what I want you to realize, and this is the point I was going to make, was we have negative and positive slopes occurring. But what I want you to realize more than anything is the slopes with the greater positive value, or the greater whole number, I should say, overall, the greater whole numbers are where you see the largest slopes or the steepest slope. So these three would have the steepest slopes, and we can actually confirm that. B, A, and E. If I look at B, A, and E, they have the steepest slopes. B, A, and E. These are very steep slopes. Whereas when we get a fractional amount for our slope, such as 1/2, -1/4, what we're going to see is that for D, we get a really flat curve, and for E, we get a really flat curve. So the greater the integer value is, or the greater, I should put it this way, the greater the amount of the whole number, regardless of if it's positive or negative, you see that it's a very steep curve, versus if it's a fractional amount or a very fractional amount, we see that the slope is very flat. All right, now reviewing the cases of different lines here. So if we look at a horizontal line, we know horizontal lines have this form here where it's just directly across. It only has one y value and a bunch of x values. If we look into our equation, y = mx plus b, a slope of 0 means I type in 0, or I put in 0 for my m value. Therefore, my equation just becomes y = b, where y = b represents specifically just a horizontal line through any given y point. And more importantly, it's through a y-intercept of 0k, or some y value there. Vertical lines are the opposite case scenario. I have this type of line here. It's one x value with a bunch of different y values. We know the equation is just simply y is equal to whatever the point is. In this case, we have x = k, or x is equal to whatever y values. And even up here, maybe I should substitute this as x value. Y = the x value represents the horizontal line, and x = the y value represents that vertical line through some given point where it has an x-intercept of whatever that a value is here. Now, if we wanted to truly match up to the problem that's being asked here, we would actually sub it in according to what's asked for as the x and y-intercept. So when we have a y-intercept, or when we have a horizontal line above here and a y-intercept of 0k, then we could say the equation is just simply y is equal to b, or whatever the y-intercept value is. And then below, we can say that the x-intercept, or when we have a vertical line, the equation is always just x is equal to whatever the a value is that represents the x-intercept. All right, in example 3, determine the equation of these lines, a horizontal line that runs through the point 5 and -3. Well, if it's a horizontal line running through 5 and -3, horizontal lines have a consistent y value. The equation automatically just becomes whatever the y value is. So if the y value is -3, therefore our horizontal line is equal to y is equal to -3. We have a consistent y value directly across. There's only one y value, so it must be that we just have a y = -3 representing this line. Similarly, if I have a vertical line instead, well, a vertical line has the same x value for every single point. So if I look at this, it would be that x is equal to -2, or whatever that x value is there, because we know that it shares a consistent x value for all the y points. Example 4, given the equation of a line, let's algebraically determine the x and y-intercepts. Well, in order to determine the y-intercept, x must be equal to 0. When x = 0 in our equation, it's 4 times 0 plus y is equal to 2. 4 times 0 is just 0, so we get y is equal to 2. This is our y-intercept. If I want the y-intercept now, or if I want the x-intercept, I have to set y equal to 0. So the opposite variable. When I set y equal to 0, I get 4x plus 0 is equal to 2. 4x is equal to 2, and if I divide both sides by 4, I get x is equal to 2 over 4, or 1/2. And this is representative of our x-intercept. Now, determine whether the point 2, -6 and -1, 4 lie on this line of the equation here. So this equation represents a line. We want to determine if these points lie on this line. How can we do that? We can just plug in the points. If these both represent the xy ordered pairs, then what we're going to do is take our equation, which was 4x plus y is equal to 2, and we're going to sub in each of these points to that equation. So starting off with our first values for x and y, we're going to plug them in. So it's 4 times 2, and then minus 6 is equal to 2. 4 times 2 is equal to 8 minus 6. And we get 2 is equal to 2. Because left-hand side equals right-hand side, perfect. So yes, this first point is on the line. Now we go to our second case scenario, or our second xy point. We plug it in. 4 times negative 1 plus 4 should be equal to 2. Well, 4 times negative 1 is negative 4 plus 4. And that would give us 0 is equal to 2, which definitely is not true. So therefore, this point, negative 1 and 4, is not on the line because our left-hand side did not equal our right-hand side. Example 5, a line is defined by this equation. State the slope and y-intercept of this line. Well, we know that any given equation must be written as y is equal to mx plus b, which this is the general form for a given linear line. So we have to rearrange our formula here such that we have y isolated. 3x minus 2y is equal to 8. I isolate for y by subtracting the 3x across. I could equally add the 2y across, but I'll do it this way. 3x, or my bad here, negative 2y is equal to 8 minus 3x. I'll carry this off to the side here. We have negative 2y is equal to 8 minus 3x. We'll divide both sides by the 2. And if I divide both sides by 2, I get y, and this more importantly should be a negative 2. I get y is equal to 8 divided by negative 2, which is negative 4. Negative 3x over negative 2 gives me a positive 3x over 2. And now if I want to reorder this in terms of the general slope equation or general slope-intercept form, this is going to be 3x over 2 minus 4. Therefore, off to the side here, our slope is our m value, or the coefficient of the x term. Our slope, which is equal to m, is equal to 3 over 2. And our y-intercept is always the constant term, which is equal to negative 4, or the one without the variables here. All right, example 6. The equation of a line is defined by y equals mx minus 6. If this line passes through a given point, determine the value of m. What we want to realize right away is they give us the equation, but they also give us an x and y to use. So what we're going to do here is we're going to plug in our x and y into the equation to determine the value of m. Y is equal to mx minus 6. They told us right here the x is 2, the y is 4. So we're going to have 4 is equal to m times 2 minus 6. In order to isolate the m, I'm going to go plus 6 and plus 6. That is going to give me 10 is equal to m times 2. And if I want to isolate the m here, the last part I have to do is divide by 2. Thus, or therefore, we get an m value equal to 10 divided by 2, which is 5. So the m value that makes this equation that passes through that given line is m equal to 5. All right, example 7, similarly, they say, what if I give you an equation as follows, and it passes through some point, but instead now we want to determine the value of b, or the constant term, the y-intercept. We're going to do the same process. I'm going to establish that this is x and y. They gave us an x and y that we can plug in. Y is equal to negative 3 over 2x plus b. We plug in y and x. 7 is equal to negative 3 over 2 times negative 4 plus b. 7 is equal to negative 4 divided by a positive 2 will result in a negative 2. And negative 3 times negative 2 is 6 plus b. Finally, we want to subtract away 6 from both sides. Thus, or therefore, we get a b value of 7 minus 6, which is 1. So our constant term, or the y-intercept as we could even put it, is equal to this 1. All right, last example. Determine the equation of a line that runs through these 2 points. In order to have an equation, what we need is the slope and the y-intercept. So in order to determine the slope and the y-intercept, let's start off by using the skills we learned in lesson 3 about determining slope and then apply it to this lesson. 2 points, we want to label one as x1, y1 and one as x2, y2. The further left point is going to be this point, which will be x1, y1, and this point will be x2, y2. To determine the slope, we need our first part, m, is equal to y2, which is negative 3, minus y1, which is 18, divided by x2, which is 2, minus the negative 4, which is x1. This gives us negative 21, divided by the double negative becomes a positive, and I have 6. And if I divide these both by 3, I get negative 7 over 2 as my slope. All right, now we have a slope, we have points, we need our y-intercept. So in order to determine our y-intercept, let's set it up here. 2, y equals mx plus b. We now know y is equal to the slope, negative 7 over 2, x plus b. How do we get the b value here? We can take either one of our points and use them. So I'm going to take, let's say, our first one here and label that as my xy point to use. If I use it in this equation, well, I sub in the y value, which was negative 3, is equal to negative 7 over 2. X value was equal to 2 plus b. We realize that the 2's are going to cancel because 2 divided by 2. Negative 3 is equal to negative 7 plus b. Last step is to add the 7's to both sides. Therefore, I get a b value equal to negative 3 plus 7, which is 4. And this is symbolic of our y-intercept. So piecing this all together, our steps 1 and 2, now that we have a slope and a y-intercept, our equation therefore is equal to y is equal to negative 7 over 2x plus 4. There is the equation we're looking for with the slope and the y-intercept. Now, here's what I want you to realize too, is that we put it back with y and x as blank variables here. Reason being is because we want to describe the whole line. We don't want to use specific points here. We want to describe an entire line. So when you go back to an equation, when they say determine the equation of a line, what they're actually looking for is the equation with our slope and our y-intercept put in with y and x put back into place. All right, now time to check your understanding. Make sure you're getting your practice. Tons of work to do with slope, tons of work to do with the problem solving, figuring out what slopes are in different contexts, figuring out what y-intercepts are in different contexts, and graphing. This is all really big skills that you're going to need to practice.